Chip chip. Probably. Okay. Uh, right. So start off. Hello. How are you guys? How are you guys doing? Doing fine. Excellent. All right. Just without further ado, I guess let's just get started. So for the first question, it's giving us a curve, 9e power 2x plus 16 over ex minus 1, And over here on 1a, it's asking us to uh, rearrange this into, well, not really rearrange, find the dy over dx and then arrange dy over dx is 0 into this form. So, first thing to do, of course, we gotta differentiate it first. Um, how to do that is we use the differentiation rule of let's say f over g d over dx, f over g d over dx. Basically, turns it into f f prime g plus fg prime. Well, wait, hang on, not plus, minus fg prime. Hang on, where's the? Hang on. Shit. But yeah, f prime g minus fg prime, and then you divide it by g squared. That's the rule, that's the rule for the f over g, which is basically this form, right? 9e2x plus 16 is basically the f, and ex minus 1 is basically the g. So you apply that over here, and then after that, the dy over dx, you got this 18e power 2x, jibber jabber. After you got that form, it's asking for dy over dx, or like the stationary point, the stationary point, which is basically dy over dx is equal to 0. So then after that, you change dy over dx over here, turn it into 0. 0 is equals to 18e power 2x times, the differentiation that we just got. And then after that, we got this. Now, the reason why ex minus 1 squared here is gone is because you cross multiply it with 0, which basically just makes it 0. Deletes it. And then after that, you can simplify the upper part of the differentiated function, and then you get the one on the bottom here that I highlighted over here. And then after that, after you simplify it even more, you'll get this over here. And from here, we have a little pattern here, right? We have e to the power 2x, e to the power 2x, e to the power x. It's asking for e power of x times, from here we can tell it's like quadratic, right? It's kind of like quadratic form times ex. So with that being said, we can take out an e to the power of x, and it will become this, right? And then, oh, it's so slow. And then after that, you just factorize this. Yeah, you just factorize this equation over here into the quadrant, like the quadrant equation over here into well, this is into this, which is basically the final answer. That's basically how you do 1A. 2B, it's asking to show us if like it's asking us to show that this graph right here only has one stationary point. To do that, we have the factors right here, right? You have like ex 3x minus 8, 3ex plus 2. Now we just need to find the root. The roots, we find it, of course. We find the roots. E to the power of x is equal to 0. That's non-existent solution, no solution at all. And then we have 3ex minus 8 is equal to 0, right? And then we do the, after we find the root, we find that x is equals to ln 8 over 3, which is valid. And then 3x plus 2 is equals to 0, has no roots. The reason being is because when you continue this, you would get ln minus 2 over 3, which if you put it into your calculator, it would just give you math error, basically non-valid. So you only have one root here, which, yeah, meaning one stationary point only. And then after that, wait, is it asking for? Oh yeah, and it's asking for the exact coordinates of the stationary point. So just to find the y coordinate, we just need to put the x in that we got earlier. This one, we just need to put it into the original function. Then after some little bit of counting, and then you would get y is 48. So the coordinate point for the stationary point is ln 8 over 3, 48. That's 1b. On to the next number. A curve has an equation. Y is 2 plus 3 ln x over 1 plus 2x. Find the equation, the tangent to the curve, at the point 1.2 over 3. Give your answer in the form ax by plus c is equal to 0, where a, b, and c are integers. So basically, finding equation of the tangent, you would need the gradient of the tangent. If you want to find the gradient of the tangent, that means you need to find the dy over dx first, and like the dy over dx, you need to find it first. And then after you find the equation for dy over dx, mic's still working. And then after you find the equation of the dy over dx, you can put the x that you were given into the dy over dx equation, and then you can find the gradient of the tangent from over there. So like number one, first thing, dy over dx, you use the same differentiation rule, like f over g. It's the same process basically to find the dy over dx as like 1a, and then after you find the dy over dx, which is 3 plus 2x minus 6x ln x over x times 1 plus 2x over squared, you can find the gradient of the tangent by putting in the x coordinate, which is just 1, put it into the dy over dx, and after a bit of calculation, you can find that the gradient of the tangent on that point is 5 over 9. After that, you can find the equation of the tangent by using the y minus y1 is equals to m times x minus x1. But before that, you need well, never mind. And then you can just put that in, the y over here, from here, the y, the tangent 5 over 9, and the x. You put it into this, and then after this after this you kind of just it's asking for ax plus by plus c is equals to 0. So you just need to rearrange this equation into what it wants, which you can just calculation times 9, so that the 9 over here to what was it to cancel out the fraction, and then after that you can rearrange it, and the outcomes 5x minus 9y plus 1 is equals to 0, which is basically your answer.
Thanks.
Okay. Good luck.
Okay, so for number 1, function f and g are defined for all real numbers valued of x by these functions over here, where c and k are positive constants. It is given that g inverse is equals to this. So for a, we are told to show that g of x equals to this. G of x means that the function fx is inside of g. So to do that, you first write the function of g, then you put the function fx inside of g, which is over here. Then right after that, you expand the function, then it will show that g of x equals to this. But we still haven't solved for this. So we use this function, and then we correlate it to this function. We combine it over here, then we will get this equation. So right after that, since we already managed to find 2c, you substitute it to this function, then it will give us a result of this, which proves that this is true. For b, we are told to transform the graph. So first, according to the orders of graph transformation, we need to first do the translations. It is mentioned that it is translated by this amount. So it is first translated on the x-axis. The translation is shown by this. Next, it is translated on the y-axis. The translation is over here. And then you simplify the expression. Right after that, you stretch the graph in the y direction. Because it is stretched by the factor of k, you multiply it over here. Next, the graph is reflected on the x-axis, so you add this. For c, to find the values of c and k, we already know that hx is less than or equals to 15. So we use the previous equation, and we know that this is the vertex. The vertex will be used for later. From this, we know that x equals to 2. And we also know that the a coefficient is negative, so the y that occurs is maximum. Y is maximum when x is 2. Given that function x is less than or equal to 15, you substitute the value of x to the equation. So we get this. Next, we do the vectorization to find the values of k. And then to find the value of c, you substitute this value of k to this, then you'll get that the value of c is 11 over 2. For number 2, this is talking about the orders of transformation. So first, over here, the graph is translated on the x-axis by 1 unit to the right. So to write that, you put this on the equation. Next, the graph is reflected across the y-axis, mirroring the left and right graph. So to show that the y-axis, that there's a reflection on the y-axis, you put this sign. And lastly, there's a stretch on the y-axis by the scale factor of 2 over here. So you multiply everything inside over here with 2. So for this number, we actually already did it on this part, so just copy it. Then we could conclude that a equals to 3, b equals to -1, and c equals to -1. That's all, sir.
Don't forget to look at the audience as well.
Yeah. Okay, so for number 3a, we express 3x squared negative 12x plus 14 in the form of 3 bracket x plus a squared plus b, where a and b are constant to be found. Okay, so first we need to put it into the equation where 3x squared negative 12x plus 14 equals to 3x. The 3 we put it out and we put the rest into the brackets, so we become 3x bracket x squared negative 4x plus 14 divided by 3 over 3. So for the next step over here, it's still the same. The 3 will be out also, and we just insert the other values into the brackets, but instead we put also the negative 4 over 2 squared and negative 4 over 2 squared, and this is still the 14 over 3. For the next step, the 3 is still out, and we try to expand the brackets. So x squared negative 4x will become x minus 2 squared, and we just try to simplify this into negative 4 plus 14 over 3. And then we just go on with the equation. For 3, it's still the same. We try to simplify it. 3x minus 2 bracket squared, and we simplify this, the negative 4 plus 14 over 3 into negative 12 plus 14, and negative 12 plus 14 will become positive 2, so it's just 3 bracket x minus 2 squared plus 2, and for the a and b values it will become a equals to negative 2 because we take it from inside the brackets, the negative 2, and the b we take it from the outside bracket, will be plus 2. Now for question B, the function fx equals to 3x squared negative 12x plus 14 is defined for x k, where k is a constant. Now the question B asks us to find the least value of k for which the function f inverse exists. So basically f inverse exists is when fx is a 1-1 function by restricting its domain. The line of symmetry is x equals to 2, so the domain x more than or 2 becomes the least value where k equals to 2. So basically the k is 2. And then for the rest of this question, you should assume that the k has the value found in part B. So we for the rest of the question, we just assume that the k is 2. For C, first we need to find an exponential for f inverse x. So fx will become, taken this equation from the questions before, so fx will become 3 bracket x negative 2 squared plus 2, and then we change the fx equals to y because we need to find inverse, so it will become y equals to 3 bracket x negative 2 squared plus 2, and then next step is we change the x into y, so y equals to 3x bracket x squared plus 2 will, we change the y into x, it will become x equals to 3 bracket y negative 2 squared plus 2. And then for the rest of this equation, we just try to, this negative 2, we change it to negative, this plus 2 we change to negative 2. So x equals negative 2 equals 3 bracket y minus 2 squared. And then basically what we're trying to do is just, we're trying to simplify the y, so the y will become alone. So after we change the 2 into x negative 2, and then we do the same in the next steps. So basically after this, the y will become alone, and it will become equal to square root of x negative 2 over 3 plus 2. So after this, we can just change the y becomes to f inverse. So yeah, this will be the final answer. Okay, for D, hence or otherwise, solve the equation for f of x equals to 29. So we do this general, put this into equation, f of x equals to 29. And then we also don't forget to put the f inverse into this. So for the f of x, we bracket it, and then we multiply it by the f inverse, so it will become like this. And then for the rest, so if we simplify this, it will become into fx equals to into the square root of 29 negative 2 over 3 plus 2, because we take this as a reference also from the previous answers. So if we simplify this 29 negative 2 over 3 plus 2, it will become 5, the value, so fx equals to 5. And then also the fx equals to 5. After that, we also multiply it again by f inverse. So f inverse fx will, since we already got the fx value of 5, so it will become f inverse bracket 5. And then after this, it's just simply putting value. So x will become square root of 5 minus 2 over 3 plus 2. And then if we calculate this, it will become x equals to 3. Okay, so for number 4a, I, the function f is defined by fx equals to x plus 1 over 2x minus 1. And for x lower than half. So for the first question, we need to state the value of f negative 1. So f negative 1 is very simple. It's basically we just input the negative 1 into the x into this equation. So it will become 2 negative 1 plus 1 over 2 negative 1 plus 1. And if we calculate it, we get 1 over 3. Okay, so for I, the diagram shows the graph of y equals to fx, which catch the graph of y equals to f inverse x on this diagram. Show any relevant mirror line. So the mirror line is basically this straight dotted lines. You can see here the line from, yeah. And then for the black one here, the black line, if the line is the line of fx, and for the blue line is the line of f inverse. So the question asks us to find an expression for f inverse x and state the domain of function f inverse. So first, since we already get the equation y equals to 2x plus 1 over 2x minus 1, we get this equation from the previous questions, because fx is same as y. And then after that, we change the y and x values. So we just basically y equals to 2x plus 1 over 2x negative 1. It will become into x equals 2y plus 1 over negative 2y minus 1. We just change the values and nothing else. And after this, to make it balance, we put the 2y negative 1 into the left part together with the x. So the x will become multiplied by 2y minus 1, and the 2y plus 1 also stays. And then after this, we basically just multiply this, the x times 2y over 2y negative 1. So it will become 2xy negative x, and the 2y plus 1 still stays the same. And then how we like put the x into the next side. So 2xy negative 2y will become equals to x plus 1. And then after this, basically we put the 2y out of the bracket. So in order to get the simplified value of y, we just need the y value. We do this 2y bracket x negative 1 equals to x plus 1, and then basically, since we only need to get the y and not the 2y, and then the 2 will become put into here. So this will be the final equation, and the question asks us to state the domain of function f inverse. So the domain is basically just this 2 bracket x minus 1 will become 0, and x is 1. Based on the graph f inverse x, the domain is x less than 1. Okay, so for b, the function g is defined by gx equals to 3x plus 2, and we need to solve the equation for fx equals to gf 1 out of 4. Okay, since this question, we also need to the equation also from the previous question, fx equals to 2x plus 1 over 2x minus 1, and here is shown that the gx is equals to 3x plus 2. Okay, so how do we put this into an equation? So basically, since it's asks us to solve the equation of fx equals to gf 1 over 4, so we just put the gf first. So g will become bracket of fx, and we basically just substitute the numbers into this equation. That will become this equation. So the x is, we get this gf 1 over 4, so we substitute the 1 over 4 into the x, so it will become g bracket f 1 over 4, and yet the equation, the rest still stays the same, except the x also, these two x's we substitute 1 over 4 also. So after we calculate all of this, the final answer will become negative 7. Okay, since we already got the value of negative 7, so we put the other equation into fx equals to gf 1 over 4, since this is the equation for us to solve. Okay, so the fx value we already got is 2x plus 1 over 2x minus 1, and the gf value is gf 1 over 4 value is negative 7. So we will have this equation. And then if we simplify this equation, we put the 2x negative 1 into the negative 7 side, and so the 2x plus 1 will be alone, so it will be 2x plus 1 equals to negative 14 plus 7, because 7 we multiply it by 2x minus 1. So we just simplify it, we just switch the values and numbers around. It will become 16x equals to 6, and x will become 3 over 8. That's it.
Is it shared yet?
Yeah. Okay. Number 5 and 9.
Okay, so for number 5, we're given the function of 3 plus 6x minus 2x squared for the domain is for x for every real number. And for A, we're given the task to basically change the form from this to completing the square. And for that one, basically you just want to remove the coefficient of minus 2x squared. So you factor it out to become x squared minus 3x. And then B here, minus 3, you divide it by 2, and then you square it, so it becomes 9 over 4. And because this a coefficient that you added in yourself, a constant that you add in yourself. You have to remove it from the function to keep it original. So here 9/4, basically to counter this 9/4, you need to minus it by 9/4, right? But because the when you expand it, it becomes negative, then you actually need to add in 9/2, which is 9/4 times 2. And then you just simplify it, and then you turn this into square, and then you have this, the final form. Now, the question also asks us to find the vertex from this form, which is just 3/2, and the x is 3/2, and then the y is 15/2. Why this works is because completing the square actually gives us the form where it tells you how small that this term can be, and that gives us the minimum or maximum point of 15/2. Because x minus 3/2 squared is always positive, so basically the function here is at its maximum or minimum when the x is at 3/2, and that gives us the y value of 15/2. So because this is the a here is negative, so the graph actually looks like this, so it's concave down. So 15/2, the vertex is actually here, so the range is basically 15/2 and everything below it. So the function of x is always the function of x is always smaller than 15/2. Okay, so now next to b, it's given that the function is transformed to hx by reflection in one of the axes followed by a translation. Now the important point here is that it says minimum point. Like I explained earlier, the function actually looks like this. So the vertex is actually the maximum point. In order to change this, the maximum point, into a minimum point, then it's actually needs to be reflected across the x-axis, so it becomes like this. So the maximum point becomes the minimum point. So this one, you need to reflect the function with the axis of symmetry of x-axis. So it becomes from like this to like this. And then it also says that the vertex is at the origin. So after you reflect it along the x-axis, the vertex becomes this 3/2 and minus 15/2. Because, okay, let me just do a simple sketch. So basically the graph first of all looks like this, and when you flip it, it becomes like this. So the x doesn't change, but the y is flipped from positive to negative, and the distance across here is the same, so it's just, you just multiply it by negative. So given that the vertex now is at 3/2 and minus 15/2, to change it into to make the function have a vertex at the origin, so you have to minus it by 3/2, the x-axis, you have to shift it by minus 3/2, and then you shift it up by 15/2. So that's it for B. Okay, now we have to sketch the graph for y equals to gx, but with the domain of x is always less than 0, less than or equal to 0. So without this domain, the graph actually looks like this, and the vertex here is 3/2, 15/2. So you just draw this part over here. So this one you just erase it, and then you just draw this part, which looks like this. And you're asked to explain why it's a one-to-one function. So for parabolic functions or quadratic functions, it's actually many to 1, because for many values of x, it gives the same y value. But if you cut it with this domain, so you actually only use this part, right? So this part isn't in the graph, it's outside of the domain. So for this domain, right, it's always 1 to 1, because one value of x always gives a different value of y. And for this one, for D, you're asked to sketch the graph of y equals to g inverse of x. That one you just need to reflect it with the axis of symmetry y equals to x here. And then you're asked to find an expression for g inverse of x. So this one is the original function y equals to gx in the completing the square form. And why we need to use the completing the square form, because if we use the original function 3 plus 6x minus 2x squared, you're gonna have two terms with y in it, and that makes it much more complicated. So what you actually want to do is just use the completing the square form, so you only have one x and one y. And then this one you just need to flip it and then simplify it until you arrive at this point. Now the important point here is you're given that for gx, the domain is x is less than or equal to 0. So that gives us the domain of gx is the same or equivalent to the range of the inverse. So if gx is less than or equal to 0, then if x is less than or equal to 0, then g inverse of x is less than or equal to 0. Because this one is quadratic, so when we root it, you actually get plus or minus. So how do you pick? Is it plus or is it minus? You use the range. So because this is the determining term, because it has to be less than or equal to 0, then this has to be negative. Okay. And then that's it for question 5. Now moving on to question 9. Okay, so this one is about the sine graph. Okay, in A, it's given that sine x is first reflected in the x-axis. So how that looks like is like this. Yeah, basically just this graph, and then you flip it. And then it's asked, how do you transform the graph I drew earlier, into this? So two things that you need to realize is that the amplitude is larger now. From it's like this thin, and then it becomes this thick. So that's definitely a stretch in the y direction. So you need to multiply it by 3. Why? Because this one here, the amplitude is 1, and here the amplitude is 3. So from 1 to 3, you just multiply it by 3. And then the second thing is that this line y equals to 0 is now moved here. So from 0 to minus 2, you just translate it with the vector of 0, minus 2. Okay, and then for this one, B, basically everything that's in A, you just convert it into this form. So as you can see, there's no changes in x, so it remains the same. But first of all, it's reflected in the x-axis. So you multiply it by negative first, and then you stretch it with scale factor of 3, and then you move it down 2 units, which is given by this. And it's all changes in the y direction, so there's no change here.